Hello, I'm Aidan Harding. I'm Technology Director at Nebula Consulting, and I'm excited to talk to you today about Apex. So these days, Salesforce developers have quite a few different tools and languages that we can use, but Apex has always been there and will continue to be the main way that we get things done in the database. So as we go and look at these other tools and see all the fancy things that they can do, sometimes when we come back to Apex, our Apex could feel a bit ugly. Rather than just kind of giving up there, what we could do is see what we can learn from these other tools and see if we can translate some of those ideas back into Apex. And that's what we're going to do in these minutes that we have. So we're going to go on a journey. We're going to look at a couple of different small problems. We're going to tackle them with a few different languages, and then we can see how that may affect what we would do with things in Apex when we come back, and hopefully we have new eyes to look at Apex with. So the first problem we're going to look at is good old classic of sorting, which is great because it's conceptually simple. I don't really need to tell you about what sorting a list is. And we're going to sort it using a library function. So if we already have a library function, sorting a list should be really simple. And we're going to find out how simple that actually looks. The one thing about sorting, which is slightly more complicated, is that the sorting criteria might change. So if we've got a application that's interactive with the user, they might legitimately want to sort by first name at one point and then last name later. The funny thing about sorting criteria is that given any particular list, you could come up with a criteria by which you could just assert that the list is already sorted. So really, this whole concept of criteria for the sorting is the interesting part when it comes to using a sorting library. So what are we going to sort? We're going to sort a list of accounts, all located in zero index town, so that we can easily check that the resulting list is properly sorted. So the shipping street is just the numbers 0 to 4, and we can just check that the array indexes when we've sorted them match up to the shipping streets. So if I think about how I'm going to do that sorting, roughly speaking, I know that Apex lists have a sort method. So I'm going to call sort, and then I'm going to loop through the list and make sure that the index does indeed equal the shipping street. Then everything will be sorted. However, the standard sort method has its own interpretation of what ordering it's going to place on those account records as it sorts them. And that criteria doesn't match the one that we want of shipping street. So if you're familiar with that, you'll probably be familiar with the idea that it can sort objects that implement the comparable interface. So what we would have to do is write a wrapper class for each account that implements the comparable interface. Each of those wrappers are going to be constructed taking an account record and a field that we want to compare on. So we're trying to write a little bit of a generic wrapper here that could compare on any field, just to be a little bit more general. So to do the comparison, all we need to do is pull the value for the given field from each of the two objects that we're trying to compare, and then we can call compare to on those values that we get. So we can write a wrapper, and then the first step in our implementation is to go through all the accounts and put them into wrappers like this. So we're constructing the S-object comparable from an individual account, and also the field definition to say it's shipping street that we want to sort them by. Now, you look at this and you may be thinking, well, there's a great big gap there. And you may also notice that what we end up with here is a list of sorted wrappers, whereas what we actually wanted was a list of sorted accounts. So there's one final stage, which is to unwrap all the accounts again at the end. Now I look at this and I look at what we were trying to achieve, which was sorting using a library function, and think this is actually quite a lot of code for a fairly simple thing that we were trying to do. It's doing some object-oriented stuff. It's got this comparable interface, but still it's quite a lot of code. So could there be a better way? Well, let's have a look at how it looks in JavaScript. If I've got an array of accounts in JavaScript, a standard JavaScript array has a sort method, just like Apex does, except that this one takes a parameter. And the parameter for a JavaScript sort is a function that tells it how to compare any two accounts so that it can put them into the right order. So our kind of outline implementation here is we call the library function like we did in Apex. We verify that everything's sorted after that, and the only thing missing is how to define this compare by shipping street function. It turns out in JavaScript that's super simple. It just takes the two records that we want to compare and calls the underlying compare method on the shipping street from the left, given the shipping street on the right. And that's it. That's all you need in JavaScript. It's much more succinct. There's no extra cost of going through a loop and putting all the data into wrappers and then taking data back out of the wrappers. All the complexity in this implementation is essential complexity to what we're trying to do. It's all involved with defining what the ordering is, just call the library and verify. There's none of that accidental complexity, which isn't actually part of the problem. It's just part of how we decided to solve the problem using wrappers. So what is it about JavaScript that makes it better for solving this kind of problem here? One thing is that JavaScript treats functions as first-class objects. In JavaScript, you can quite happily pass around functions the same way as you pass around objects in Apex. That enables the JavaScript libraries for sort to use a strategy pattern where it has a general sorting algorithm where one part of it is defined externally, and you're passing in the strategy to compare any two items within that list and finalizing exactly how that sort's going to happen. The comparison function that we're writing in JavaScript is also a pure function. It has no state. It keeps the data and the functionality separate, which means that anytime you call that comparison function on the same data, you're guaranteed to get the same answer. There's no internal state change that could happen within that function, which makes, as a reader of the code, it makes it easier to understand what's going on. So could we try and do this in Apex? So one of the keystones of the previous Apex implementation was the comparable interface, which assumed that the thing that we were comparing had some data in it. Instead of doing that, we could write our own interface, comparator, which looks more like the JavaScript one. It takes both sides that it needs to compare, and it doesn't wrap anything. It can just be a pure function. So let's go ahead and write a comparator in Apex for our example. Just like before, we're going to be a little bit generic. It's going to be constructed with the field that we want to compare on, but notice we don't have to pass the record in anymore. And the actual comparison function is simpler as well. It pulls the values out of the left and the right-hand side, and then it just calls the underlying compare to function on the values. Once you've got that, if you have a list sorting implementation that uses the strategy pattern, it can be used like this. So we just call sort, pass in the list of accounts, and pass in our comparator function saying that we want to sort on shipping street. Now we've got something that looks just as simple and direct as the JavaScript. You may notice from this code example, there's a little nebc in front of the lists there, and that's the namespace from our Nebula Core library that we use, which is an open source library which implements many of the ideas that I'm talking about here. This talk's not really a sales pitch for the library, it's a sales pitch for the ideas behind the library, but you can get the code for the library and also the code for all the examples here from the links that I'm going to give you at the end. So enough with the sorting example. Let's move on and look at a different problem in a different technology. So we're going to pick another very simple problem to solve. Here, all we want to do is set the rating on accounts as they're inserted by simply looking at the industry. So if the industry is biotech, we're going to set the rating to hot. If the industry is technology, we'll set it to warm. And if it's chemicals, we're going to set it to cold. And we're going to split the implementation across the different technologies that we're using so that we can have straightforward implementations that don't have to switch themselves on and off and all can live within the same org. So if you're going to do that in basic Apex, this is going to look quite familiar to a lot of people, I think. We would write a before insert trigger, loop over all the records in the trigger context, and if the industry is biotech, we set the rating to hot. Looks very simple, doesn't have any apparent accidental complexity, and it just works. So let's have a look at how that would be done in Flow now. So in Flow, just like in Apex, we can have a before save record triggered flow, where the flow is running as the record's on its way into the database, so we can change some values before it actually gets committed, and we don't need to do an extra update here. There are 3 nodes in this flow. The end node doesn't really count because it's just a finish that does, for visual reasons, it doesn't actually do anything. So really there are just 2 nodes in this flow. The start node has some entry criteria. So we're only going to continue with this flow if the account that we're processing is a technology account. If it passes through those entry criteria, we're going to set the rating using the assignment node. We're going to set that rating to warm. So it's all very simple inside the flow. There are just 2 nodes there. And let's see what's good about the flow implementation. It's bulkified by default. So within Flow, I haven't had to write a loop over all the records within the trigger context. It's just assumed that the flow is going to apply to all of them, and the flow framework is going to handle applying my flow written in terms of a single record to everything within the trigger. Flow is also working at a higher level of abstraction. When I'm writing my flow, I'm writing things in terms of my intention. I'm not telling the computer exactly how to do this. I'm not telling it that it has to do a loop. I'm not telling it that it has to have explicit branches in this flow. I'm just saying that these are the only records to consider, and this is what you have to do with them. And that kind of feeds into the third point, that this kind of flow is a declarative implementation. It's not imperative. It's not telling the computer step by step, do this, do this, do this. It's just conditions and assignments applied uniformly to collections. You can write flows which are more imperative and look more like Apex, where they have loops in them and things, but this set of flows which just use declarative constructs are much easier to write, much easier to understand, and actually provide you quite a lot of utility. So could we do something like this in a text-based language instead of just Flow? Go back to our friend JavaScript. Inside JavaScript, the array object has some operations which are similar to Flow. They apply to the whole collection simultaneously, and they work with these kind of high-level constructions. So we could take a list of accounts and we could filter them to just the ones where the industry is chemicals, and we can set the rating to being cold. So this has the same sort of nice properties as the Flow of being high level, working on collections in a kind of symmetric way, and very nice. So what about Apex? Can we do a Flow or JavaScript style Apex? We're still going to have a before insert trigger here, and reading this, you'll see that little clue, the nebc namespace here. So this is something that we've written to implement some of these ideas. So the list of accounts from the trigger context has been wrapped inside an iterator, which is going to act a bit like Flow. So it's going to bulkify it for you, and then everything following on from there is going to be written in terms of each individual account as it passes through. And we can write the same sort of operations as we saw in JavaScript. We can filter these accounts, and then we can apply a function to them to modify them. Question is, what's going to go in these TBD comments there? Well, what needs to go in there is some functions, some Apex objects acting as functions. And just like before, the key to doing this is to define some interfaces that we can implement. And our objects that implement those interfaces will be the functions. So the filter operation is going to take a Boolean function, and the for each, where we're applying a changes to the accounts, is going to take a function which just receives an object and returns an object. So it allows you to make some changes to the things as you go through. So specifically, what are the implementations of those to make that happen? We write a Boolean function which checks whether the current account is a chemicals one. And then we write a function which assigns the rating of the current account to cold. And we can plug those straight into the implementation that we saw before. So we're iterating over the new list, filtering to just the ones where the industry is chemicals, and then we're setting the rating to cold. And now we've got a piece of Apex that looks just as straightforward and simple as the JavaScript and the flow. You may be thinking that if I were to adopt this style, I would suddenly end up with hundreds of tiny little classes like isChemicals and setRatingCold. Because one thing that Apex doesn't have that JavaScript does is that it doesn't have anonymous classes or lambdas. You have to explicitly create each of these little classes to parameterize these functions. But actually, a lot of the time that we're working in Apex, we know that we're working on lists of S objects. So rather than just having a generic iterator like this, we could actually build a different kind of iterator that's specialized for working on S objects and has some even higher level operations than filter that allow you to get the same effect without having to write your own custom classes. So here, if we're iterating over a list of accounts and we know that they're S objects, we can have an S object iterator. And if we have an S object iterator, then it can have these operations that are specific. So our filter now becomes filter on field, where we just have to tell it the field and the value we're looking for. And because it's S objects, we can have a put operation that for each account is going to put the given value into the given field. Now we've got something that really does look a lot like the JavaScript, and we haven't had to write loads of tiny little classes. And so you may be continuing to object to this. You might be thinking, well, this is great, but can I actually do anything useful with this in the real world? Well, one of the nice things about having a framework like this is it solves some of the everyday problems that you would have. Even if you're writing everyday imperative Apex, one of the common things that you may want to do is something like this. If you have a list of contacts, you might want to pull out all of the account IDs from those contacts. So normally we write a for loop, but if we've got this iterator library that knows about S objects, we can just directly get that in a single line. And you can imagine that because these things construct together, you could do something slightly more nuanced without a great addition of complexity. So there could be a filter in there before the get if there were only certain accounts you wanted to include. Taking it to a bigger example, this is some real world code that I wrote for a customer where they have a custom object called workspace that is integrated to an external system. And what I needed to do in this trigger is every time a workspace changes, if any of the fields that we have mapped in the external system have changed, we need to requeue this workspace so that it will be resynced to the other side. So in the outline of the code here, we're constructing another iterator, but this is an iterator that's aware that it's iterating over the pair of the old list and the new list from the trigger context. So each time we do any filtering or mapping here, we have access to both the old and the new record. So we're going to start from that iterator, we're going to end up with for each, and we're going to fill in the middle part. So the first thing we're going to do is apply a filter. You'll see this is a very high level construct here. We're saying filter to just the records where any of this list of fields has changed. And that is saying very concisely what you would have to say with a whole load of conditionals and for loops if you're working in a more imperative way. So once we've gone through to pick out the records where one of the mapped fields has changed, we can forget about the old record and stop iterating over the pairs, just start iterating over the new records. Once we've done that, we can apply another filter and say, has this particular record already been synced? We don't want to update it if it doesn't already exist on the other side. So we can have a filter on field where the external ID is not null. Then if everything else is okay, we can go in and set the integration status to pending, and an asynchronous process will pick that up later and send it to the other side. So this is an awful lot of utility in a very compact piece of code. One of the great things about using Apex to do this kind of coding is that unlike Flow, you've still got the whole of Apex. If these abstractions are not working for you, you can just stop using them and you don't have a massive change to your implementation. You just have maybe some of this stuff, then a bit of imperative Apex, then maybe a bit more. You can use it where you need it and you have no big jumps from hitting the wall with what's possible within what you're trying to do. But you may still be objecting. You may be thinking, well, this is all too complicated. No junior developer is ever going to understand this. But I think one of the key points in my mind is there's a difference between how easy something is to make and how easy something is to use. If you look at these two hammers, I could probably have a go at tying a rock to a stick and build the one on the left. I have no idea what goes into constructing the steel hammer on the right. But if I had to build a tree house, I would want the hammer on the right. It's very clear which end you use for hitting things and which end's better for pulling out nails. And it's going to last the whole time. So easy to make is not the same as easy to use. If we make a lot of thought up front to design something well, it'll be easier for someone to come into the project and read that code than if we'd written reams and reams of long code with no abstractions in it. And the other point is that simplicity is really about clarity of purpose. If we break everything down with these sorts of abstractions, the whole thing's much easier to understand because there are smaller parts, each of which has a single purpose. So to sum up with some final thoughts on this, look outside of the things that you do day to day. If you only program in Apex, then it's well worth your time, even if you don't have a demand to write Lightning Web Components, to go and learn something about JavaScript, because it can give you new ideas. And when you first go to a new language and you're baffled by everything, actually, that's one of the most fruitful times because you haven't accepted all the standard ways of doing things and you've actually got fresh perspective on that. And this is really going to blow your mind, but there's stuff outside of Salesforce. There's general developer conferences that can teach you a lot, and you can bring things back to what you do in Salesforce. Read about patterns. Patterns are like the meta language that allows you to translate ideas from one programming language to another. If I see something in JavaScript and I want to turn it into Apex, it's the patterns that allow me to have a way of thinking about it that can write it from one way to another. Beware the idiom. Idiomatic things are often things, idiotic things that we do automatically. We don't even realize because we do them every day. So if you have live code templates built into your IDE that automatically generate 20 lines of boilerplate code to do something for you, you should be really suspicious of that sort of thing because it may be easy for you to generate those 20 lines of code, but some mug is going to have to come along and read that in 6 months' time and understand that 20 lines of code. Whereas if you take the time and you come up with an appropriate abstraction instead, that can be much more descriptive to them of what your intent was when you were generating all that code. The last point is don't take scissors to the recipe. This kind of way of looking at your code can suggest good abstractions and good ways of breaking up your code into smaller pieces. If you treat your code like a recipe and you just cut it in this kind of temporal way of this is the first 10 things that I do and I'll chop it there. And then there's the next 20 things and I'll chop it there. That kind of way of breaking up the code doesn't necessarily result in things that are easy to understand. If there are lots of connections between the first 10 lines and the following 20 lines, then it's still very hard to understand. Whereas if you take a more thoughtful approach to breaking up the code and use abstractions, it can give you a better system overall. So I promised you some code. Here are some links. First link, if you want more comics like the sorting one earlier on, head over to SMBC. If you want all the code from my code examples in this presentation, go to that first GitHub link. And if you want to have a go with our Nebula core library, this is not a sales pitch, then you can have a look at that. I would love you to use the ideas in that. I'd quite like you to use the library, but absolutely have a look at the ideas. Talk to me on social media or on the questions that we're just about to start if you want to chat about any of that stuff. Thank you very much.